Cartesian equations of a line from parametric form. Okay, so now we normally know if R is equals to um, a plus lambda b, and R is equals to xyz, and a is equals to x naught y naught z naught, and b is equals to element. Well, in that case, we know x is equals to x naught plus uh, lambda L, and y is equals to y naught plus lambda M, and z is equals to z naught plus lambda N are the parametric equations of this specific line. From this, how we can find the Cartesian equations? Okay, how can we find the Cartesian equations? We will make the lambda as the subject. We will make lambda the subject. So in equation 1, if I make lambda the subject, we can say x minus x naught is equals to lambda L. So lambda is equals to x minus x naught over L. Okay. Similarly, for the equation 2, we can do, and we will be coming up with lambda is equals to y minus y naught over m. Similarly, for the third parametric equation, I can say lambda is equals to z minus z naught over n. Okay. See, in these three cases, first case, second case, third case, in all these cases, lambda is a common value. Okay, lambda is a common value. So I can say x minus x naught over L is equals to y minus y naught over m is equals to z minus z naught over n. Okay, so this is the parametric form converted into Cartesian equations of a line. Okay, this is how we can convert Cartesian parametric form of a line into Cartesian equations of a line. Okay, well, so we have three forms. Okay, we have three forms: vector form, parametric form, and finally we learned about which form? The Cartesian equations. Cartesian equations. Vector form is just R is equals to a plus lambda b, where a is the position vector and b is the direction vector, and lambda was any real number, and R is the equation for line. And parametric, R is the vector of line. Parametric equation says that x coordinate of the vector R will be equals to x naught plus lambda L. Y will be equals to y naught plus lambda M. Z is equals to z naught plus lambda N. And for Cartesian equations, we have x minus x naught over L is equals to y minus y naught over M is equals to z minus z naught over n. These three equations must be really clear for you. Okay, you should be really thorough with these three types of equations. You should be able to mix them up and find the parametric equation from the vector. Okay, and from the parametric equation, you should be able to find the Cartesian, and it's vice versa. And also you have to be able to find out the Cartesian equations from vector, and you can reverse the process. See an example before we move forward. Okay, before we move forward, let's see an example. You can derive the Cartesian equations from the parametric equations. Okay, so let's say we have x is equals to 1 plus 4t and y is equals to 2 plus 5t and z is equals to 3 plus 60. Okay, it doesn't always has to be lambda. Okay, it can be any other variable. So now we can convert it into Cartesian equations of a line by x minus 1 over 4 is equals to y minus 2 over 5 is equals to z minus 3 over 6. Okay, so this is how you have to convert from parametric to Cartesian equations. Now we get back to the important one. Okay, now we get back to the important one. The Cartesian equations from vector. Okay, let's say we have a vector like this. Okay, so the similar thing, x by z is equals to uh, x0, y0, z0 plus lambda into lmn. Well, what you have to do is you will write x here, you will subtract what's here, x naught, and you will divide it by L. And you will put a equation equal symbol, and you will put a y here, you will minus the y naught, and you will divide it by m. Similarly here, z minus z naught over n. That's all. This one is not appreciated. Okay, you shouldn't. I'm not gonna say you shouldn't do this, but if you go to parametric equation and then come to the Cartesian equations, that's better. Okay, because you might make mistakes if we have minus, plus, and all. But if you find the parametric equation, it will be very. We can confidently say that we are doing the correct way. Okay, so for example, I have to give an example for this also, right? So let's say r is equals to, okay, let's say r is equals to minus 3, 4, minus 7 plus mu 2, 3 minus 2. Okay, so now we can say x plus 3 over 2 is equals to y minus 4 over 3 equals to z plus 7 over minus 2. This is the Cartesian equations. Okay, the Cartesian equations are the Cartesian equations of this specific straight line. Okay, very good. Now, let's say we have something like this. Let's do the reverse. Okay, what if we had the Cartesian equation and we have to turn it back to vector form? Yeah. So let's say there is equation like this: x minus 3 over 2 is equals to y plus 7 over 9 equals to 5 minus z over 6. It's like this. Okay. So first of all, what you have to do is you have to convert this into parametric equations. For that, it's better if I have z in positive number, z as the positive number. So what I'm going to do is I'm going to rewrite this z minus 5 is over minus 6. Okay, I'm multiplying both sides by minus. Okay, now I can say this is equals to a real number and a parametric number, something called, let's say, t. So I can say x is equals to 2t plus 3. 2t plus 3. Similarly, y is equals to 9t minus 7. And z is equals to minus 60 plus 5. Okay, so this is the parametric equations. Once we have the parametric equations, it's just easy work. Okay, it's just easy work. Why? You can rewrite this into 3 plus 2 t into 2. And this will be minus 7 plus t into 9. And this will be equals to 5 minus, you can say 5 plus t into minus 6. Well, then you can say r is equals to a plus tb, where a is equals to 3 minus 7, 5. Okay, 3 minus 7, 5. And b is equals to 2, 9 minus 6. 2, 9 minus 6. Okay, 2, 9 minus 6. Or as we did earlier, without moving to another step, we can directly write that down. Okay, we can also directly write that down. If you have something like this, x minus 3 over 2 is equals to y plus 7 over 9 is equals to z minus 5 over 6, or minus 6. Was this the question? Wait, did I write the question wrong earlier? No, I have been writing the question correctly. So this is not minus 6, this is 6. Okay, so we will rewrite this as, we don't have to rewrite, yeah. c minus 5 over 6, so it's not an issue. Okay, so is this the correct question? C minus 5 over minus 6 it should come. Okay. Okay. So if we have something like this, how can we directly go to the vector equation? Okay, that's the $1,000,000 question. So you can say R is equals to A plus TB or lambda B, that's your wish. Okay, and you have to mention A is equals to the negative of this number, the negative of this number, and the negative of this number. Okay, so you can say 3 minus 7, 5, and that will be equals to A. And B will be equals to the number in the denominator. Okay, you don't have to change anything. It will be just 2, 9 minus 6. You can also do that. Okay, you can also do that. That's your wish. But I prefer, first of all, if we have vector form, I will convert into parametric form, and then only I will convert into Cartesian equations. Okay, that's how I will do. Okay, and why I will do this, why I normally prefer this is because let's look at another example, and you will be able you will also be able to understand. So let's say R is equals to A plus lambda B, where A is equals to 1, 2, 3, but B is equals to minus 1, minus 2, 0. Okay, well, according to the plan, okay, so we have vector something like this 1, 2, 3 plus lambda into minus 1, minus 2, 0. According to the plan, okay, if I have to write that down, well, I will say x minus 1 over minus 1 is equals to y minus 2, y minus 2 over plus 2, minus 2 equals to z minus 3 over 0. Can I divide a number by 0? No, we can't divide a number by 0. So that's not right. Okay, so that's why I prefer, first of all, rewrite this into parametric equations. Okay, rewrite this into parametric equations. So it will be x is equals to 1 minus lambda, y is equals to 2 minus 2 lambda, z is equals to 3 plus 0 lambda. So which means z is equals to 3. Okay, z is equals to 3. It is a fixed number. Okay, only x and y are going to change according to lambda. Now I can write that down, the Cartesian equations, as z is equals to 3. Okay, z is equals to 3, and I can say x minus 1 over minus 1 is equals to y minus 2 over minus 2. Okay, that's it. This is what we have to learn about the vector equation of line and parametric equations of line and Cartesian equations of a straight line.
Thanks for watching the 14th video in our vector series. If you found this explanation of Cartesian equations of a line helpful, don't forget to like, share and subscribe for more tutorials. Hit the bell icon to stay updated with our latest videos. Check out the full playlist of master vectors and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.